Hi all, today we are going to discuss about bus admittance matrix, how to form the bus admittance matrix and why we prefer only the admittance matrix and the nodal analysis, and followed by some numerical. So for that I am taking one 4 bus system. I am taking the bus, this is 1, 2, 3 and 4, and the voltages at the respective buses I am taking as V1, V2, V3 and V4, as well as the power that is injected I am representing by SI, that is injected, and the power that is taken to the load that I am representing by S suffix D. D stands for the demanded or drawn from there. So SD respective buses. So how to make the analysis of this one to form the Y bus? So to form the Y bus, first we have to construct the equivalent circuit so that we can apply the nodal analysis easily. So for that what I am doing, whichever buses are there I am taking as each one as one node. So bus number 1 I am taking as one node, bus number 2 I am taking as second node, third node and the fourth node, and this whatever voltage is there, that voltage is applied between this bus and the reference or the ground. So that's why I am taking the ground as my reference or the neutral point as my reference. So this is my ground or N. So the voltage V1 is applied between the node 1 and the ground. Getting it? So now let us assume the shunt admittance of bus number 1 I am representing by Y1 with respect to N. And similarly bus number 2 Y2N, bus number 3 Y3N and bus number 4 I represented by Y4N. And similarly the current supplied by the each bus I am representing by I1, I2, I3 and I4. And now between these two, whichever transmission lines or buses are connected, you can see bus 1 is connected to bus 2. So between bus 1 and 2 I am representing that by Y12, that is the admittance, and similarly between 1 and 3 also connected, so between 1 and 3 is Y13, between 3 and 4 also connected, that is Y34, similarly 4 and 2 are connected, Y24, but 1 is not connected to 4 as well as 2 is not connected to 3. So by adding them, what is going to happen, how the circuit will change, that we are going to discuss in the coming sections today only. So now I have to apply the nodal analysis for calculating this. Nodal analysis means the sum of the currents at any node will be equal to 0. We have to apply that. So let us try to apply the equations first. Then we will see the advantages of the nodal analysis and following the admittances. Let us try to write the current equations. So then we will proceed further. So I can write the current entering is equal to I1 is equal to current leaving. What will be the current leaving? This V1 multiplied by Y1N, because this is directly connected to this one, plus V1 minus V2 into Y12, that is also connected to node 1, and similarly between node 1 and 3 also there is a connection. So this will be equal to V1 minus V3 times of Y13. Only these are connected to node 1. You agree with me? So V1 into Y11, V1 minus V2 times of Y12, V1 minus V3 times of Y13. Or simply I can write, separate the components outside. This will be V1 multiplied by Y1N plus Y12 plus Y13. You can see that whatever the admittances are connected to node 1, all are coming here. So admittances connected to node 1 are Y1N, Y12 and Y13. All are multiplied with V1 minus V2 multiplied by Y12. So V2 is the second side that is connected to node 1. Node 2 is connected. That I am multiplying with Y12, I am taking the minus sign here. Similarly, the third one is becoming equal to V3 multiplied by Y13. In this form I got. So similar way I can analyze the current I2. So current I2 I can write as, what is the value of current I2? Again current entering is equal to current leaving. So this will be equal to V2 multiplied by Y2N, V2 multiplied by Y2N plus V2 minus V1 multiplied by Y12. Got it? So plus V2 minus V4, because between node 2 and 4 also there is connection, V2 minus V4 times of Y24. V2 minus V4 times of Y24. So similar is the case, I can write for the value of I3. So I3 also will be equal to I3. I3 means from the node 3. From the node 3 what is there? V3 multiplied by Y3N, that is 1. And between node 3 and node 1 also there is connection. That means this is node 3 minus node 1 voltage multiplied by Y13. That is because of node 3. Between node 3 and node 4 also there is connection. So this is V3 minus V4 times of y3 4. So in this way I can calculate the I3 because I3 is having only 3 elements, 1, 2, 3 elements are connected to this node. So similarly I can calculate my value of I4. So for the fourth node it is V4 multiplied by Y4n that is connected. Similarly between 4 and 3 that is connected. So V4 minus V3 times of Y34 plus V4 minus V2 times of Y24. These are what connected. So similar way we can simplify them, and when we simplify them and write in the form of a matrix, so I can write as I1 will be equal to, so what we have to do, all the admittance that are connected to that node, that is Y1n plus Y2n plus Y13, because Y12 and Y13 that are connected, multiplied by V1, and minus V2 multiplied by Y12 minus V3 multiplied by Y13, and V4 is not connected because there is no connection between node 1 and node 4, so it becomes equal to 0. So similar is the case, I2 will be equal to minus Y12. Similarly this is a 2 and 2 because this is one second row second column. So again this will be sum of all the elements that are connected, you will get, this will be 0. So in this way you will get the matrix in this form. So here in this matrix you can see these are the diagonal elements, whichever the diagonal elements are there, so that I am representing in this matrix form. I is equal to Y multiplied by V. So this I am representing I1, I2, I3, I4 is equal to, so this is the first row, that's why I am representing with Y1, first row first element, that means Y11, first row second element Y12, Y13, Y14. Similarly this is the second row, so Y21, Y22, Y23, Y24. Similar is the case others, and here this constitute two things, one is the diagonal elements and non-diagonal elements. So you can observe here these diagonal elements whatever are there, they are coming by taking the sum of all the admittances connected to a particular node, and off diagonal elements you can see here minus Y12 is coming, here also same thing is repeating. That means whatever is the non-diagonal elements that follows the transpose, that means if you calculate one part of this one, so automatically this will be replica of this one only. That is the advantage of going for this admittance matrix. In the admittance matrix what happens, whatever are the upper part are there, same thing is repeating here. Let us take for example there is a n element node, so total number of elements are n multiplied by n. So out of this n multiplied by n, so diagonal elements will be equal to n, because total number of diagonal elements will be equal to total number of nodes. So n cross n minus n, out of these elements they are just repeating, so divided by 2. So only these many elements I have to calculate, that means either upper non-diagonal or lower non-diagonal, plus these diagonal elements also I have to calculate. That means total these many elements I have to calculate. So total elements which I have to calculate is n cross n minus n divided by 2 plus n. So these many elements if we calculate, you can easily construct this matrix. Getting it? So this we are going to discuss in detail in the coming sections. So that's why I am just erasing here, because here I feel to tell. So now I am just summarizing this one. So I can write I as Y multiplied by V form, where this diagonal elements YII I have represented with the blue color, where I is equal to 1, 2, etc. up to capital N, where N is the number of nodes. It is equal to driving point admittance, or it is also called as a self admittance of node I. Because it is II, it is a driving point admittance or self admittance of node I. This is nothing but the algebraic sum of all the admittances terminated at that node. So whichever admittances are connected to that node, either between two nodes or it is between that node and the ground, whatever is there, whichever admittances are connected to that node, take the algebraic sum. So that will gives rise to YII. That is a summary we have seen here. Then similarly, off diagonal or non-diagonal elements, that is Yij or Yji, because it is symmetrical only, Yij is equal to Yji, where I is not equal to j, that gives the off diagonal elements. Again j is 1, 2, etc. up to n. Similarly I is also 1, 2, etc. up to n. This is called as a transfer admittance or mutual admittance. What is the meaning of this admittance? It is the admittance connected between two nodes. So if you are taking the node I and j, whichever admittances are connected between I and j, you take the algebraic sum of all the admittances and keep the negative sign before that one. So take the negative sign before that one. Just for example, here capital Y12 is equal to minus Y12. You can see minus is coming. Whatever is the admittance, I am taking the negative sign. Getting it? So we can summarize from here, I will be equal to, which is a n cross 1 matrix, because we have seen above, this I is n, because total 4 buses are there, n is equal to 4 here. This is 4 cross 1 and this y is 4 cross 4, that means it is n cross n, and v will be again 4 cross 1. 4 cross 1 is 4 is the number of nodes. So that's why it is equal to 4n cross 1. This n is the number of buses. How many number of buses are there? So if you want to calculate at any node k, I can calculate by ik. So ik, so let us take for example again going here, I want to calculate I2. So I2 how I will calculate? You have to take this second row elements multiplied with this. So this means y21 multiplied by v1, y22 multiplied by v2, y23 multiplied by v3, y24 multiplied by v4, or simply I can tell in this form ik of the second, that is equal to sigma n is equal to 1 to number of nodes yki, yk, that corresponding value of n here, ykn multiplied by vn. In that form you can get it. So I am summarizing up to here what we have learned. So if you are taking a 4 bus system, so first thing what we have to do, you have to represent the per unit diagram. So per unit diagram, either it will be directly given in the numerical, or you have to calculate the per unit diagram based on the diagram that is given in the exam. So per unit circuit diagram, how to draw, we have already discussed previously in fault analysis. You can please refer there. Once the per unit diagram are drawn, then we will go for the nodal analysis. For that we will draw the equivalent circuit diagram like this. So once this circuit diagram is drawn, we can calculate the Y matrix easily. What we have to do, this is Y11. So Y11 will be for this particular node, which elements are connected. You can see Y12 is connected, Y13 is connected, and Y1n is connected. Take the sum of those elements. So Y1n, Y12, Y13. Similarly, 22 means second element. For the second node, you can see what elements are connected. Y12 connected, Y24 connected, Y2n connected. I have taken the sum of them. Similarly, 33 means third node. Which elements are connected? Y3n, Y34 and Y13. So just take the sum of them. Similarly, 4 also same thing. For the node 4, what are connected? Y34, Y4n, then Y24. So those things we have taken the sum. Now coming to the off diagonal elements. Off diagonal elements means, let us take for this element. This is nothing but equal to Y12, capital Y12. Y12 means between node 1 and 2. What elements are connected? Between node 1 and 2, only one element is connected, that is Y12. So that Y12 I will take with a negative sign. Let us assume multiple elements. It is a parallel transmission line. So multiple elements will be connected. So take the algebraic sum of all the admittances and keep the minus sign. So in that way you have to calculate. So similar is the case, this element. This is between node 1 and node 3. Between node 1 and node 3, Y13 is connected. Similarly, between node 3 and node 1, between node 3 and node 1, it is nothing but equal to Y13 only. That's why same thing is repeated here with negative sign. So in this way you have to represent it. So once you understand the basic, I think it is very easy to form the Y bus. So similar is the case. Now let us see what will be the effect of adding a new line, because in transmission line I told you that load flows are used for future expansion also. So already load flows are designed, I want to expand the thing. So what I want to add one more line here. So let us assume I want to connect this node number 3 to node number 2. I have added this one more extra line. That means I have connected node 3 to node 2. So one more transmission line is added here. So when the transmission line is added, automatically the series element is added here. So this will be equal to Y23 or Y32, whatever you calculate it. So Y23 is extra added, and along with this transmission line the shunt elements may also add. So accordingly the shunt elements will be updated. Let us take the example, only series admittance is added now. So when it is added, what changes will come in the circuit? So where this Y23 is connected? Y23 is connected between node 2 and node 3. It is connected between node 2 and node 3. So where node 2 and node 3 is there? So this is 1, 2 and 3. This is node 2 and node 3. So this will be equal to minus Y23 here. So similar is the case. So node, this is 1, node 2. So 3 also 1, 2. So here also it will be added in the same way. So this will be equal to minus Y23. So this will be equal to minus Y23. Here I forget to keep 0, right? So this is the value 0. Okay. So now minus Y23 is added here. Now what are the other changes that will add? Again it will add in the shunt this respective self admittances also. Where is the self admittance? Of admittance of node number 2 also will change. Admittance of node number 3 also will change. So admittance of node number 2 means this node. So here also we will add this Y23. So similarly, admittances of self-admittances of node 3. So here also it will change. So Y23 will add here. So you can see here where the changes came, total 4 changes came in your diagram. So advantage of going for the admittance is whenever any new line is added or anything is added, you can see simply we are adding those elements. Similarly, whenever some network is disconnected, only we have to delete that particular element. So that is a major advantage of going for admittance method instead of going for the impedance method, as well as going for the nodal analysis. Nodal analysis, we can just simply add and subtract only. This is the double advantage of going for nodal with admittance method. So again I am repeating here. So again here, just how to calculate, let us summarize, then we will go for a numerical. So I want to calculate for the value of I1 or Y11. So Y11 is all the elements connected to node 1. What elements are connected? Y1n is connected, Y13 is connected, Y12 is connected. You can see it is done. So between node 1 and 2, this is between node 1 and 2. Between node 1 and 2, Y12 is connected, we have to take minus, so minus Y12. Between node 1 and 3, so Y13 is connected. Between node 1 and 4, 1 and 4 are not connected, so that's why it is 0. Similar is the case between node 2 and 1. 2 and 1 what is connected? Y12 is connected, you have to take minus sign. Y22, all elements connected to node 2. That is all elements connected are Y12, Y23, Y24 and Y2n. So all these elements I have added here. Similarly between node 2 and node 3, what is connected? Y23 is connected, minus we have to take. Similarly between 2 and 4, minus Y24. Similar is the case for the node 3 and the node 4. So in that way you have to analyze. I hope how to form the Y bus is clear. So let us take one small example to understand this concept clearly. So in a 3 bus system shown in the figure, it is given Z2 is equal to 0.1 plus J 0.2, Z5 is J 0.5, Z8 is J 0.1 and remaining that shunt elements they are given as admittances only. Y1 is equal to Y3 is equal to J 0.02, Y4 is equal to Y6 is equal to J 0.04, Y7 is equal to Y9 is equal to J 0.02. This is the diagram that is given. This is the diagram that is given. So it is asked to calculate the Y bus. So you can see for calculating the Y bus, I need only the Y elements, but here Z are given. I have to convert this Z to corresponding Y. How to convert? We know that Y is equal to 1 by Z. So Y2 is equal to 1 by Z2. So let us calculate it later on. So Y5 will be equal to 1 by Z5. This will be equal to 1 by J 0.5. 1 by J 0.5 if you take, J comes to numerator, so it becomes minus J. 1 by 0.5 is 2 minus J2. Similarly, Y8 will be 1 by Z8 minus J10 will come. So how to calculate this Y2? Y2 I have to calculate as 1 by Z2. This is 1 by 0.1 plus J 0.2. So to calculate it, what I can do? I can just multiply with the complex conjugate. Complex conjugate of this one will be 0.1 minus J 0.2 divided by 0.1 minus J 0.2. So when you multiply it, A plus B into A minus B is A square minus B square. So we know J square is equal to minus 1. So minus into minus become plus. You will get it as 0.05 and numerator is 0.1 minus J 0.2. This is there. So when you simplify it, you will get as 2 minus J4. So now we have calculated all the impedances into admittances. This is Y1, Y2, Y3, Y4, Y5, Y6, Y7, Y8. So first we have to form the Y matrix. Then we can add the respective things accordingly and substitute there. So now just try to follow. So now coming with the node 1. So Y11 I want to calculate. So Y11 will be equal to sum of the admittance connected to this node. Agree with me? So what are connected? Y1 is connected. Y4 is connected. Similarly, Y5 is also connected to this node. Y2 is also connected to this node. This Z2 I have to convert to Y2. Getting it? So between node 1 and 2, because this indicate between 1 and 2, Y2 is connected. So take minus of that one. So minus Y2. So similarly, this one is between node 1 and 3. Between node 1 and 3, what is connected? Z5. That means minus Y5 is connected here. So similarly, between node 2 and 1, Y2 is connected. And 2 means all elements connected to node 2. This will be equal to Y2 plus Y3 plus Y8 plus Y9. So you have to take the sum. Similarly, between 2 and 3, Z8 or Y8 is connected. Take the minus sign. So minus Y8. Similarly, coming to the bus 3 and 1. Between 3 and 1, Y5 is connected. So minus Y5. Between 3 and 2, minus Y8 is connected across this one. So now coming to the self node of 3. So that will be equal to self admittances. So all the elements that are connected to this node, that is Y7, Y6, Y8 and Y5. So all those elements you have to take the sum. So in this way you have to form the Y matrix. So all the Y matrix we have calculated here. So take the sum of the corresponding elements. For the first one, Y11 will be Y1 plus Y4 plus Y5 plus Y2. I have taken the sum and this value came. Similarly, the second one Y22 is Y2 plus Y3 plus Y8 plus Y9. I have taken the sum, I got this value. Similarly, the Y33 is Y5 plus Y6 plus Y7 plus Y8. When you do the sum, you got this. So now whatever elements are here, same elements I have represented here. This will be my final value of Y bus. So in this way you can how to form the Y bus matrix. So I hope how to form the Y bus matrix, why we are going for the nodal analysis, what are the advantages, why only we are going for the admittance diagram, and how to make the changes when a new branch is added or deleted is completely clear to you. So if you still have any queries related to this, you can leave your comments in the comment section below. I will answer to your queries from there. Thank you very much.